Hello, Alan Mgeni here, going through local search algorithms and adversarial search. Begin with hill climbing, a local search algorithm that starts from a randomly selected solution and continuously moves to a better solution. Here, we look at visiting the neighboring states to find out the best possible maybe solution. But the main thing with hill climbing, imagine you have puzzles, a puzzle game which you have to solve, and you have to go puzzle by puzzle. So you list the neighboring puzzles to solve them. And one challenge you can have with that is what we call, you can get stuck in local optima. Local optima is just a good solution. It's the best solution within the neighbors, but it's not the best solution within the entire sample space. So maybe we shall look at what we call global optima as we continue. Okay, we have simulated annealing. This one you aim at. Annealing is something like you in physics you can hit something then pull it further to get what you want. So in simulated annealing, we basically get a solution and model it until we find out the best solution out of that. So it is meant to solve the problem of local optima that we saw in hill climbing. This can apply in maybe pattern recognition, for example, in images and sounds. If you're trying to compare them, you can use what we call simulated annealing. You go to genetic algorithms. Genetic algorithms consider it is more of evolutionary. It has some kind of natural selection in it, and it is used to generate high quality solutions. In genetic algorithms, we are going to see that we have successor states, and these are as a result of combining the two parent states. For example, I have a solution combined with another, then I can generate a super beta solution from these solutions. So this is what we call genetic algorithms. Here we're capable of looking at a very big sample space, but the main problem with this is we have high computational costs, difficult parameter configuration, but applications you can have neuroevolution. In neuroevolution, we look at developing of neural networks and maybe also in games, for example, developing strategies. And now, how to improve usability of these algorithms using responsible AI and explainable AI, you can see when you have hill climbing, simulated annealing, genetic algorithms, as well as this helps to improve user trust and transparency. We can also look at in explainable AI, we have to make clear explanations of the decision-making process. So you need to make the user understand why certain solutions were chosen or neglected. And if you look at simulated annealing, this can help make things, the process more intuitive and understandable. Look at responsible AI to avoid bias. These things help us make solutions justly and hence promoting fairness in the search process. We can go to adversarial search. Adversarial search, we are looking at having two competing agents. One is trying to maximize and the other is trying to minimize. So more so in player zero sum games, for example, you have some chess there. One person is trying to win the game, and then the computer is trying to make that person fail. In adversarial search, you're going to have many algorithms, min max. You're going to have expect max, as you're going to see. In min max, shall have maybe you're trying to consider. Okay, we can first look at expect max, where you have stochastic games which are played under uncertainty. Yeah, you have a certain value of randomness, for example, in dice and cards. Yeah, alpha beta pruning, you're basically trying not to visit nodes that may not make a difference to the outcome. We go to adversarial machine learning, it's a subfield of artificial intelligence. We have white box attacks, black box attacks. In white box, you basically know the model's architecture and parameters. Black box, you don't know, so you just have to create the outputs and learn more about it. Then we have remaining attacks, poisoning attacks, evasion attacks, model extraction, inference. And then how is adversarial machine learning related to adversarial search? You can consider the adversarial nature, where we have two competing entities. For example, in adversarial search, you can have maybe say the model and then the person playing the chess. Then both of them are meant to optimize performance. Yeah, but then we can conclude by saying we know in adversarial search we should know it is a well-defined sequence of moves, and then in AML, adversarial machine learning, it is more of like natural language processing. and then other tasks like malware detection and applied in real IT operations. Thank you so much. Thank you so much.